So yesterday, we ended with concept of the neutralization reaction. Neutralization immediately implies there's an acid and a base coming together, producing water and the resulting salt. Okay, so what we're going to be doing today and tomorrow, let me get rid of this first. I'm not using this. Now we're going to be doing this reaction only. We're not using hydrochloric acid though. We're using something called KHP instead. So this is going to go. And that is a special acid. And it has one hydrogen that comes off. Now, why we're using KHP, why not using HCl? Okay, the reason why we're using KHP is because it's a dry acid. When we measure stuff, it's easier and more precise to measure dry things as opposed to liquid things. The liquid measuring devices are much less precise than a scale is for a balance. So that's why we like to use a dry acid. What we don't know is the concentration of the sodium hydroxide. Now, the essence of something called the technique we're going to be using today and tomorrow is called titration. And titration is some kind of an analytical process a very, very popular technique back in the 50s before instrumentation became plentiful. So what we're doing is, in this case, this is going to be an acid-base titration. And we're going to be determining the value, the concentration of an unknown sodium hydroxide solution. Now you're going to mix up approximately 500 milliliters, and the concentration is going to be around 0.1 molar. But we need to know it exactly. So what we're going to do is we're going to take a known gram amount of the KHP acid. Now, to find the molar mass for that, it's in your write-up. Don't think the P stands for phosphate. It stands for phthalate. It comes from phthalic acid. But the molar mass is in your write-up. It's a pretty long formula. Okay, so if we know the moles, of KHP, we now know the moles of sodium hydroxide because we went to the point where the moles of KHP exactly neutralize the moles of sodium hydroxide. And there's a technique we're going to use to know when we get there. And that's called an indicator. And the indicator is going to tell us when that point is reached. And that point is called the equivalence point. Equivalence means equal. So equal numbers of moles of KHP equals number of moles of NaOH. So now we know, or we can calculate the concentration of sodium hydroxide, because we'll know the volume in liters and we know the moles per liter. And it's going to be around 0.1 something, depending on how sloppy you were in throwing together your sodium hydroxide starting point. It could be a 0.09, could be 0.1, could be 0.11 or whatever. It can be to 3 places. Okay, so this is the deal. So let me show you how the lab is going to go today. And remember moles, we need to know the grams times the molar mass, or KHP, for the liquid sodium hydroxide, we need to know the moles per liter, which is question mark, times liters. So all of you know how to do grams, right? We go over to the balance on the side of the room, throw it on there and weigh it to 3 significant figures with all the doors shut. Not to three decimal places, not significant figures. Okay, now as far as the sodium hydroxide goes, you're going to be using something called a burette. Or burette, if you want to pronounce it Latin-wise. All right, so the burette is a long cylinder that you've already used in lab 3. It's calibrated in milliliters. Okay, so we're going to put sodium hydroxide solution you made up, approximately 0.1 molar solution. You're going to make up 500 milliliters of it. You're going to put that in the burette. Down below is going to be the KHP. And the indicator. Now we're using a very, very popular indicator. It's called phenolphthalein. And it's colorless until you reach the endpoint. Then it turns pink. And it's a very sharp endpoint. So as soon as it turns pink, light pink, you stop. So what you're going to be doing is we're going to be dripping from here sodium hydroxide into the acid. And when the moles of acid equals the moles of base, turns pink. So now we have volume in milliliters that we convert to liters. And going up here, that L comes from the burette. You don't know what the moles per liter is. And the moles of acid is equal to grams times the inverse of the molar mass. So that's the essence of titration. Liters of sodium hydroxide, known concentration, equals moles of acid. At the equivalence point, the indicator will tell us that's happened. You could also use a pH meter. And at the neutralization point, the pH is going to be 7, like we talked about yesterday. That's considered neutral, neither acidic nor basic. Okay, so let's look at typically what a problem would look like. Okay, in this problem here, we have an unknown acid concentration instead of an unknown base. So you can calculate the base or the acid, just depends on the problem. Okay, the first lab 15, is finding the concentration of the sodium hydroxide. The second lab is finding the concentration of an acid. In this case, it's going to be vitamin C or citric acid. So what we're going to do is we're going to go drop, 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 drop on our burette into the acid and indicator, and it's going to turn light pink. And I stress that because if you go too far, it turns into Barbie pink. Really cool looking color, but you've gone over. You have to go up till it just barely turns pink. Okay, so we've got, and on your burette, there's 2 ways to run your burette. You can start exactly at 0. That would be 0.00, 2 decimal places on the burette. Or you can start anywhere you want, up towards the top. Like it could be 1.50. Doesn't really matter. If you start at 0, 0, 0, you don't have to subtract. If you start any place other than 0, you have to subtract the final and the beginning readings, and that'll get your net results. Okay, so in this case, the burette started at 2.34 milliliters, and it ended at 23.45. So we delivered 21.11 milliliters of standardized base. Okay, and that concentration is 134 moles. So the first thing to do is calculate how many moles of sodium hydroxide was delivered, because that's going to be equal to the moles of acid in there, equal 1 to 1. So let's take the 21.11 milliliters. I want to convert that to liters. Okay, that is liters now. Liters times concentration equals moles. So we want to multiply that times so step 1. And remember, molarity is moles per liter. So we multiply moles per liter times liters. Excuse me. We end up with moles. Liters cancel. Okay, so that's 2.83 times 10 to the minus 3 moles of sodium hydroxide. So we need to get moles of sodium hydroxide. So at the end point, at the equivalence point, moles of acid and moles of sodium hydroxide are equal. So now we know the moles of acid. Okay. And to get the concentration, we need moles and we need volume. Volume of the acid is 20 milliliters. Need to convert that to liters. So now we know. So to get concentration of the acid, we have 0.134, 283 times 10 to the minus 3 moles. And the volume is going to be, it was 20, right? Yeah, 20. So now we have moles per liter, unknown acid concentration. Okay, so that is a typical titration problem. Okay. You guys have any questions? Think of it as three-ish steps. The middle step is kind of, it's necessary, but it's, there's no math involved. Is equal to moles of base equals moles of acid. That's the second step.
The ambulance is base because
Sodium hydroxide, strong base.
that was just in the notes you have to memorize that.
Mm-hmm.
Okay. That's how we go.
Yeah, that's how we know.
So yeah, sure.
Now we're going to use sodium hydroxide in your lab. I don't know, you have Wednesday or Thursday?
Thursday.
Thursday.
I'm taking unit.
Test today, yeah. Okay, is there any questions about this process? I'm going to do some more examples, but it's this is the essence of your lab today. The essence of it. So the lab 15, the purpose of lab 15 is to determine the concentration of your sodium hydroxide. That's called standardizing your base. And now that we have your base standardized in lab 15, we're going to use that in lab 16 to determine the concentration of the vitamin C tablets. You're going to crush them up and do a titration. Same thing. You're going to have 2 runs, average them together for each one. And normally we do 3, but because we're doing 2 labs today rather than 1, we're going to do just 2 runs. 2 good runs. Okay. All right. Again, are there any questions? By the way, there's going to be one of these on test 5. There's always a titration question on last test. Okay, so let's do another one. Very similar. Okay. Now this assumes you already have standardized sodium hydroxide. If you don't, then you need to standardize it using a process similar to lab 15. And KHP is the standard dry acid we use to standardize sodium hydroxide bases. The problem with KHP is they stopped making it this year, quite literally. I don't know. something weird, availability wise, or not enough profit in it. That's typically the KHP. It's not your concern though, but it's a concern for our community colleges in this. Oh,
Can you, and I can't.
on the new problem? Okay, so again, with your burette, you've got to have a before and after reading. And if you start at exactly 0, then you don't have to subtract. But if anything else, you've got to subtract. So we're starting this time at 3.60, ending at 13.45. Now, this was standard stuff back in the 50s. If you worked in the clinical lab or a forensic lab for a county office, sheriff's office, or whatever, you use this every day. Every day. And there's a lot of pretty wild drugs that are acids. Can anyone think of one? Yep, that disassociates. That's right. Huh? Fentanyl. You know, there's a poster for fentanyl. Must be in one of the hallways. I don't know if that's an acid. I was thinking of LSD. The L stands for lysergic acid. Yeah, LSD. Yeah, the fentanyl is outside. I know they did one on fentanyl. If you'd like to do a drug-free extra credit too, by the way. Now that's going to be due next Thursday. That's assuming we have lab on Thursday. I mean, we have test on Thursday. Maybe we'll have a test on Wednesday. The way it's looking, we'll probably have the test on Wednesday. So whatever the last day of the test is, that's when the extra credit's due. Is anyone planning on doing extra credit? Okay, so just keep that in mind. Isaac, are you speaking for Chloe as well? Okay.
I seen that. I forget the last, but they told me they were gonna ask you to do like Google extra credit.
No, individual. And you can do together if you want to do 2 posters.
Right, exactly.
And some people do that. They'll do a kind of a yin and yang kind of poster.
Oh.
For example, I'm trying to think of one now. Like coffee and tea always comes up. You know, what's the difference between caffeine and coffee versus caffeine and tea? That's one that's been used where 2 people do posters that kind of go together. And then they give me the posters together as well.
Oh.
Because there's no presentation. It's just a matter of talking back and forth.
So
I'll look at your poster and ask you a few questions about it. And
how do they, isn't that just the same, like the individual one, just on different things? Because they're not saying how they like interact with each other.
right. Now, these posters are good examples of what you can do. They really are. And the reason why she put them up there is because they're good examples. Not for my benefit, but she just wanted to showcase. Because this is from 2B. Chem 2B requires you to do a poster. Same with my 306 class at Sac City. I require everyone to do a poster. In this class, it's totally optional. Okay, so let's get going on this here. All right, so I'm going to diagram this out so you get an idea. That's our burette, and we're starting at there and ending there. Now, this is a two-person job. It's hard to do by yourself. I know some of you like to work alone, but not today or tomorrow. The reason I'm saying that is one person swirls. It's going to be a little Erlenmeyer flask down here at the bottom. One person swirls, the other controls the dropping. That's right. That means you're not at the end point yet. It's got to stay clear. Her question was, if you swirl it, the color is going to go away. And that's correct. That's because it's not mixed properly. So you've got to swirl it until the color stays for 30 seconds. If it goes away and you haven't elapsed 30 seconds, then you have to keep dripping. Now the dripping's coming from the burette above. And the markings are in milliliters. The big bars, the little bars in between are 1/10 of a milliliter, and you're going to estimate between the little bars. Usually it's half a distance or so, or it's exactly there, but write down 2 decimal places. Okay, so how much now up in here is sodium hydroxide. So how much sodium hydroxide did we deliver? We delivered 1345 minus 360. So we delivered 985 milliliters of sodium hydroxide into the acid. Now this acid is down here, and we have the indicator. Now make sure you put indicator in there. If you don't put indicator in there, you're not going to know when you're at the end point or equivalence point. If in doubt, put it in anyway. It doesn't hurt to add extra drops. You only need like 3 drops. But if you forgot whether you put it in or not, you just add another 3 drops. Not a big deal at all.
Here is the amount of drop.
Now, the indicator tells you when you're at perfect neutralization. That's when the moles of acid equals moles of base. Until then, one's lopsided. Okay, if you didn't have an indicator there, you just drip all day and it stays colorless. Nothing. Well, the indicator tells you when you have pH 7 neutralization. Correct. It'll go from no color to pink. All right. So step one is to determine moles of sodium hydroxide. So that's going to be let's okay, so that'll convert, this converts the milliliters to liters, then the liters cancel, leaves us with moles. of sodium hydroxide. Let's calculate that real fast. Okay, so that's 427 times 10 to the minus 3 moles of sodium hydroxide. And at the equivalence point, when it turns pink, it's also equal to moles of acid. Only at that time. It's just a split instant. Now we have moles of acid over 20 milliliters of water or volume. Now we need to convert that milliliters to liters. Okay,
Oh, I got it.
oh, and this is moles up here too. And this is the moles per liter is the same as M, uppercase M. Yeah, that's right. Because it's in the denominator, it's the same as multiplying by 1,000. So you can do that separately if you want.
You're saying that's the same as 1.85,000?
No, you're dividing 20 by 1,000, but it's the same as multiplying 4.27 times 10 minus 3 by 1,000. Because it's in the denominator, you're dividing 1 over 1,000. If you're dividing 1 over 1,000, it's the same as multiplying. It's the inverse of an inverse.
Mhm.
And you can do this in 2 steps if you want. Do the bottom step, substitute it in, and then do it. Okay, so now this is basically what you're going to be doing in the second lab today, lab 16. And the unknown acid is going to be the vitamin C tablet. Okay. Um, what I was thinking, since we're doing a double lab today, I'd like to end lecture early, give you enough time to finish both labs today. And I also wanted to go over the calculations for the lab. Yeah. Because by definition, concentration is per liter. And if you leave it in milliliters the whole time, you eventually have to convert it to liters. I like to convert it along the way since it's by definition moles per liter. We just put everything in liters. Okay, so let's start lab early. That way we'll have enough time to do both labs today.